Welcome to our revision series. Today we want to look at capacitance, combination of capacitance, how you can answer your question up to your time constant. Let's start with the first question. A capacitor of capacitance C1 is connected in series with a second capacitor of capacitance C2. Show that the combined capacitance C of the two capacitors is given by 1 over C equal to 1 over C1 plus 1 over C2. This is February March 2025 paper 4.2. Not just for this series, it cuts across other series. Let's see what you can do here. When they ask you to show, it means that you have to ensure you put everything possible to get to what is expected. What is a capacitor? It's a device used to separate charge, also electric potential energy, or time circuits. Now, in the aspect of charge, charge is equal to CV. Now, if we want to make a capacitor the subject of the formula, we have Q over V. How did we arrive at this equation? Let me show you how we came to that. When we connect capacitors in series, and you know this is revision. With revision, I need to touch a few other things so that it helps you. When we connect capacitors in series, by the time the key is closed, the charge will flow to C1 to C2. The charge that gathers on C1 is the same charge that will gather on C2. However, the potential difference that will build on C1 is not the same as C2. So the potential difference will come from the EMF source, which is the battery. V equal to V1 plus V2. Remember, I said the charge will be the same. So Q is the same thing as Q1, is the same thing as Q2. Having said that, and we said V equal to V1 plus V2, it simply means, let's look at our first expression. We said that V in itself, the V total will be equal to the total charge over the total capacitance, which is the 1 over C. Let's pick this as equation 1. Let's get to the next one. V equal to V1 plus V2. It's important for you to know that your V1 will be Q over C1, while your V2 will be Q over C2. This simply means your V will be equal to Q over C1 plus Q over C2. And by factorizing it, we have Q outside into 1 over C1 plus 1 over C2. Now, comparing this with what we had as V equal to Q total over C total equal to, let's write down this Q into 1 over C1 plus 1 over C2. You agree with me that this and this will cancel, and we have 1 over C equal to 1 over C1 plus 1 over C2. So what are the things that you get the 2 marks? I started with this explanation in which you may not really start with that, but you have to show this and you have to show this. If you don't understand, ask question. Remember, you have to do everything to get maximum marks. Don't want you to miss any mark. Let's go to question number 2. 3 identical capacitors, each of capacitance C, are connected in a network as shown. We have 3 capacitors here. This is connected to 2 that are in series. It's important for you to know when capacitors are connected in series, just like the one we just finished, the total capacitance will be equal to 1 over C1 plus 1 over C2 plus 1 over C3. But when they are connected in parallel, the total capacitance will be C equal to C1 plus C2. In this case, they are connected in parallel and in series. By the time we will come here, it's important for you to know that for this one and this one, the total for the series will be 1 over C equal to 1 over C plus 1 over C, which will give us 2 over C, meaning the total for this down will be C over 2. That is what we will have here as the total. By the time we have this, now the total combination generally will now be C plus C over 2. That will give us 3 over 2C. Keep this by the side. We will come back to it. Now, the variation of the charge Q with the potential difference V between the terminals X and Y is shown in figure 5.2. Remember to check the label. This is microcoulomb and this is volt. So show that C is equal to 44 microfarad. This is total capacitance equal to C plus C over 2, which is 3C over 2. Keep this by the side. We need to find the total capacitance. For us to find the total capacitance, we will use this graph to find it. Total capacitance will be the gradient of this graph. Delta Q over delta V will give us the total capacitance. This is 6 and this is 400 microcoulomb. Total capacitance being the gradient will be equal to 400 times 10 raised to the power of, okay, we have micro here, so I may not change it. I will still change it back, divided by 6, and this will give us 66.67 microfarad. This is for CT. We now look for C. If CT equal to 3 over 2C, we will have 66.67 microfarad equal to 3 over 2C. C will be 66.67 times 2 divided by 3. This will give us 44 microfarad. You see how I did it? I used the graph to get the total, just like what we were explaining up here. Now, this is what I want you to note. Whenever you see a starting question, let's say A, from that A, it will lead to B. From B, it will lead to C. That is how physics is set. The capacitor network in 5.1 is charged and then connected to a resistor of resistance 54 kilo ohm. The capacitor network discharges through the resistor. Determine the time constant of the circuit. Give a unit with your answer. It's important for you to know that time constant is the product of resistor and capacitor. Take note of that. In this case, the resistor has been given to us, which is 54 kilo ohm. That is times 10 raised to the power of 3. The total capacitance that we add is 3 over 2C. And if this is the case, we can put it as time constant equal to 54 times 10 raised to the power of 3 times 3 over 2, and we cut our C as 44 microfarad, so times 10 raised to the power of minus 6. You notice that I changed kilo ohm to ohm. I changed microfarad to farad. You must change it. If you don't change it, it will be marked against you. Our time constant will now give us 3.56 seconds. Let's get to the next one. Determine the time taken for the discharge current to reduce to 15% of the initial discharge current. Now, this is the other part of capacitance equation. Current equal to initial current exponent minus T over time constant, which is RC. However, I is reduced to 15% of I naught, 0.15 I naught. 0.15 I naught equal to I naught exponent minus T. Now for RC, we cut the time constant as 3.56. Let's cancel this. For us to bring this down, we take natural log of both sides. So ln 0.15 equal to minus T over 3.56. So minus T will be equal to ln 0.15 times 3.56. Ln times this will give us minus 6.763. So minus T equal to that. Minus minus cancel. Our time there will be 6.76, or you write 6.8 seconds. So thank you for watching. See you in our next video.